In this video, I'll be testing an A4988 stepper motor driver with a capacity of 35 volts plus or minus 1.2 amps. With this, I'll be testing a Nema 17 stepper motor with a voltage rated at 3.1 volts and a current rated at 2.5 amps. Attaching the connections and the code in the description box below. After making all the correct connections, we can then use the red probe on the VDD pin on the driver and the black probe on the ground pin on the driver to ensure it is 3 volts or 5 volts depending on Pi's supply voltage it is connected to. So again, we use the red probe on the VDD pin and the black probe on the ground. Ensure that your multimeter is set to 20 volts DC. We see that it is 5.13 volts. We now can find V reference. V reference is needed to set the potentiometer. The potentiometer is located here. V reference can be calculated as I max times 8 times RCS. RCS is equal to resistance, which is the current resistance. In my case, V reference is equal to 2.5 amps. As previously stated, my stepper motor is rated at 2.5 amps times 8 times 0.05. Resistance can be found on your stepper motor's data sheet, but most A4988 stepper motors are either 0.05 or 0.068 ohms. 0.05 is for the original boards, and 0.068 is boards made after January 2017. But always reference your data sheet. So in this case, my V reference is equal to 1 volts. It is good practice to use a safety margin of 10%. With that, my V reference is now 0.9 volts. Now knowing V reference, we can now measure the current V reference on the board with the multimeter. Again, ensure that the multimeter is set to 20 volts DC. Now we will use the red probe to connect to the potentiometer and the black probe to connect to ground. My current reference voltage is 0.89. This is almost my exact V reference calculated. But when I first got my driver, it was at 0.3 volts. This was okay for my motor because it was lower than the calculated V reference. But if your V reference is lower and the current V reference is higher than needed, it can lead to motor overheating, loss of torque, and this can result in extruding. So you must check your current V reference. Now that we have calculated our V reference and measured the current V reference, we now know that we need to rotate the potentiometer. Clockwise is to increase V reference, or counterclockwise to decrease V reference based on the measured current V reference. Rotating the potentiometer can be done by using a ceramic screwdriver set. I have one here. I'll be using this one. I did have to sand it down to fit the potentiometer, but you can purchase one made for the A4988. Although my board was 0.89, I'm still going to increase the potentiometer and try to obtain 0.95 volts. When rotating the potentiometer, ensure you're not applying too much pressure, as this can cause a short and end up rendering your board useless. Also, rotate the potentiometer in very small movements, as moving too quickly can overheat the board. As you can see, it's at 0.98 volts. A small movement goes a long way. Due to the 10% safety margin we obtained earlier, being right on V-reference is not vital. So now, having 0.98 voltage, we can run the code. I have had my power supply disconnected, so now I will run the code and connect the power supply. When I first ran the code and had it set to its V-reference, it jerked a little bit more than this. I read a forum that said just give it a few seconds. I recommend that, as it began to rotate how it was supposed to after just a few seconds. Now I will unplug it and we can lower V-reference and see how the motor acts with that. Again, do not apply too much pressure. Okay. Let's see where we're at. Okay, just 0.79. Let's get down to at least 0.6. We can now connect the power supply. So it's still running very well here. We can lower it some more. So this is at 0.4. Still running really smooth. We can again lower it. Lowered it a little too much. Okay, so now it's at 0.1. jerking back and forth. Hope you can see that. Let's raise it a little bit more and see. So let's back it up a little bit. So here it's jerking very fast at 0.04 above the 0.1, and then about 0.05 after that it begins to run. Still with a little bit of jerking, but run rather smoothly. So let's go ahead and slowly increase. It still has some jerk to it. That's back at the 0.2. Okay, so we've done 0.2, 0.4, and 0.69, I believe. So I'm going to still move it rather slowly, but we are going to try to go up past and see what 1 volt is, and then 1 volt almost exactly, and then a little bit above that. Okay, so obviously it's starting to move more, starting to make a little bit more noise. Starting very well there at 0.8. Okay. At 0.98, I am starting to see a jerk. But like I said before, we'll see if that stops. Yes, I think it is actually stopping. All right, and then now we're just gonna go a little above. So that's 1.04. Let's see if we can get a little closer to 1.1. 1.09. That's pretty close. Let's go ahead and turn it back down. So I'm going to go ahead and disconnect the stepper motor. We saw that it ran well between 0.2 to about 0.9. It ran very well. 1 volt, it did begin to jerk in small amounts, just like at 0.14, I believe it began to jerk. And then past 1 volt, it started to jerk more and more. So 1.2 amps is its max capacity. And as I showed previously, the driver will shut off before it overheats itself. Now I do want to say that before I ordered these drivers in particular, I ordered from the same website as I got the stepper motor. The drivers were less expensive, but the first one I used didn't stop or didn't shut off when it was about to overheat. It actually completely damaged the board and I could no longer use it. So it is good to know that these work as specified.